Good morning, good day, and good afternoon, everyone. My name is Cicilia Kambey from Institute of Ocean and Earth Sciences, University Malaya, Malaysia. I'm doing research related to seaweed biosecurity, particularly in eukaryotic aquaculture in Indonesia and Malaysia with our biosecurity teamwork. So it is a pleasure for me to deliver a presentation in this special session, Seaweed Biosecurity in International Pycology Symposium ISAP2021. My presentation title is Applying Biosecurity Measure in Kappaphycus Farm and Assessment of Biosecurity Framework in Seaweed Aquaculture in Malaysia. The presentation content include first, introduction, second, the assessment of biosecurity framework in seaweed aquaculture in Malaysia. In this part, I'm going to explain how effective this national policy and regulation that implemented to seaweed stakeholder through a survey. And the third part, applying biosecurity measure in Kappaphycus farm, which is including a farm observation. And the last is conclusion. Seaweed aquaculture is a rapid expansion industry globally and represent more than 50% of the world marine aquaculture and 34% of the production concentrate in the Southeast Asian country as eukaryotic seaweed production. In 2018, the export value of the eukaryotic seaweed aquaculture reached to 1.5 billion US dollar. However, after 2015 to recent years, the production of eukaryotic seaweed aquaculture in three most productive countries such as Indonesia, the Philippines, and Malaysia have declined in trend shown by these two graphs. This decline of production contribute to decrease to the world seaweed production in 2018. Several challenges have consistent disturbed the eukaryotic industry, such as consistent of ice syndrome, known widely as a disease in eukaryotic farm. Infestation of the red filamentous epiendophyte such as Polysiponia and Neosiponia, known as Melanotamnus, can affect to the health performance and cause ice syndrome. Coverage of epiphyte, algae, mollusk, and any uncultured organism can disturb a growth rate of the seaweed. And changing environment such as increased water temperature, high variability of salinity, and lack water movement become a triggering factor to ice incidents. Repetitive in vegetative propagation can cause less resistant of the seaweed to disease. And the last is complexity in market chain. Concept of biosecurity has been widely applied in mariculture such as fish, shrimp, bivalve, commercial aquaculture to improve their breeding, production, and limited disease in farm. With importance of this concept, we apply the biosecurity to seaweed aquaculture for minimizing the consistent problem that facing in this industry. The policy and regulation that apply such a biosecurity concept is needed to improve national seaweed aquaculture industry, not only to enhance production and food safety, but also cover the introduction of seaweed disease and pest outbreak. So the purpose of this research is applying the biosecurity concept in seaweed aquaculture, but we need to know how Malaysia's seaweed aquaculture policy and regulation use biosecurity concept in managing farming system and a sustainable this industry. We need to identify, measure, and apply this concept to know how useful the biosecurity is in seaweed aquaculture and get strong evidence-based study. Second part, assessment of biosecurity framework in seaweed aquaculture in Malaysia. In this assessment, first step is identification of biosecurity concept in 4 national seaweed policy and regulation that have been used for Malaysian seaweed aquaculture, which are Fisheries Act 1985, Malaysian Good Agriculture Practice or MyGAP, Malaysian Seaweed Standard number 2467, and Seaweed Farming Manual by a Department of Fisheries Malaysia. Our result found by a thematic analysis, most policy and regulation came as a non-binding framework, but they have explicit use seaweed in their rule. They have limited use of biosecurity approach and only use precautionary and detection in most of their approach. Their policy and regulation use expert opinion and science-based study. Most of the policy regulation have lacked include a precautionary principle. To measure how effective this policy regulation in managing seaweed disease or any other farm risk, particularly in prevention and detection approach, we conduct a knowledge, attitude, and practice survey to 77 seaweed stakeholders, including 67 farmer and 10 government officer called extension officer in 3 most productive area in Malaysia, which is in Semporna, Kunak, and Tawau. In knowledge survey, the stakeholders were questioned about are they know disease and pests in farm, and are they understand of the introduction and spread of disease and pests in their farm. In attitude and practice part, the stakeholders were questioned about the external biosecurity, internal biosecurity, and general control. We also incorporate demographic factors that may influence the KAP score of the seaweed stakeholder. The KAP result showed that the farmer and the extension officer were found in a fair or moderate score of the general knowledge, but have a poor understanding of the disease pathway and causative agent of disease and pest in farm. The external, internal, general biosecurity control found a similar with the attitude and practice score, which is a fair attitude but poor in practice, particularly farmer in Semporna and Kunak, while there are become a center of seaweed eukematoid aquaculture in Malaysia. Only attitude of extension officer was found good, but their knowledge and practice also were fair. Farmer knowledge, attitude, and practice were influenced by their educational level, which is mostly up to elementary school, and their occupation as a temporary seaweed farmer, which let the farmer have low awareness to managing their farm. A lack of internal and general biosecurity control practice were identified in isolation and quarantine, crop management, and farm management part, which is a part of the prevention and detection measurement, shown in the 2 red boxes in practice graph. So knowledge and implementation gaps finding by this assessment is a first lack knowledge on disease and pest introduction by all seaweed stakeholders. Second, farmer aware of productivity risk than farm risk posed by disease and pests. Third, no surveillance system in monitoring seaweed by the competent authority and cause inappropriate practice by farmer. Fourth is no implementation of regulations such as quarantine and isolation on crop, a prevention measure on crop and environment system, and also farm management. And the fifth, if the policy regulation is need updated in the internal crop management. Third part is applying biosecurity measure in a Kappaphycus farm. We did the observation on how effective biosecurity measure in farm in a small-scale Kappaphycus farming in Gelam-Gelam village in Bumbum Island, Sampurna area in 2019 for 40 days observation. We conduct observation during disease season in this area, and two Kappaphycus species were used, which is Kappaphycus malaysianus and Kappaphycus alvarezi. Two types of farms were used as a treatment, and farm design is shown by this experimental design figure. Two types of farm as a treatment, which is one farm was conducted with a biosecurity measure and the other farm without biosecurity measure. The biosecurity treatment include propagule treatment with a visually check of health condition from beginning to the end of culture period, which is have to no bleach, no wound, no coverage by uncultured organism, and many branches and look fresh. So the cleaning treatment also used as a biosecurity measure, which is routine conduct every 2 days to clean and remove all the epiphyte, biofilm, and epiendophyte, and as well as the infected cellus, and all remove the waste and dispose in the landfill. As a preliminary result, the biosecurity measure of cleaning treatment resulting decreasing 60 to 75% of ice incident in Kappaphycus malaysianus and 29 to 71% in Kappaphycus alvarezi for 40 days culture. It's compared with the species culture in the farm without cleaning treatment. High coverage of epiendophyte melanotamnus in Kappaphycus malaysianus have correlated to high incident of ice. Kappaphycus alvarezi found more resistant on ice syndrome than Kappaphycus malaysianus. The epiendophyte melanotamnus is invisible in preparation state, so that the crop isolation and quarantine is needed. The environment parameter include water temperature, salinity, inorganic ammonium, and water current have similar value and concentration, shown by the black and the orange sign, but the result in seaweed condition and ice incident were different between two of farms. It means the cleaning treatment make a significant difference. Seaweed quality of a growth rate and gelling strength resulting difference between farms where farm with biosecurity treatment has higher in gelling strength and growth rate compared with the farm without biosecurity treatment. Result found that the cleaning treatment is a required process and important to reduce farm risk related to ice syndrome and pest outbreak. So isolation process of seaweed propagule is in preparation state is highly recommended to reduce the pest epiendophyte. Kappaphycus alvarezi is more resistant to ice syndrome and pest melanotamnus species than Kappaphycus malaysianus. Further study are recommended to replicate these biosecurity measures in the bigger scale of farmer and in different seasonal variation to strengthen the supportive evidence base. And then additional biosecurity measure of isolation on crop is needed to be investigated in further study. So conclusion of my presentation are: first, biosecurity application and measure are important to seaweed Kappaphycus aquaculture and industry. Second, evidence-based study is needed to prove the importance, the application for improving the industry based on policy recommendation. So thank you very much for listening my presentation.